Hello scholars, welcome back to the Kemet Maasai Academy. Today we're going to be looking at sets, the union and complement of sets. Now we have a whole series of videos on sets at different levels, grade 4, grade 5, as well as sets for high school. So just check the playlist and find the video that you want on the particular subtopic in sets. So whether you want just focusing on the Venn diagram or intersection, or as we're doing now, complements and union, or you want to look at the number of elements in the set, all of that we have covered. Just check the playlist and we have it all for you. Before I go any further, let me urge you, if you have not yet subscribed to the channel, please do so now, because the more subscriptions we get, the more the video will be accessible to other students, the more readily they will find the video in their search. So subscribe, share the videos so that other students may benefit. Let's go. So we're looking at the union and complement of sets. As you should know by now, the universal set talks about all the elements being considered, and we use the Venn diagram to represent the universal set. So here is our Venn diagram. Capital U at the top to indicate this is our universal set. These are all the elements that we are considering. Now we have in this Venn diagram, we have 1, 2, 3, 4, 5, 6, 7 different sets. And I've deliberately done this in order to explain to you how we write the union of, for example, disjoint sets, how we write the union of subsets, how we write the union where sets intersect in this way. So this was very deliberate. It's not that I want to crowd my Venn diagram, but I just want to make sure that you see the different ways that we would be expected to write the union and complement of sets based on how the sets are interacting with each other. If two sets do not intersect, such as set S and set T, they do not overlap, we say that they are disjoint. And their intersection would be the empty set or the null set. However, even though they are disjoint and they have nothing in common other than being a part of the universal set, that's the only thing they have in common, they still have a union. You still can list the union of that set, those sets. If two sets are arranged in this way, as in set U and set V, wherein set V is contained within U, all the elements in V are within U, are also elements of U. So we say that V is a subset of U. In this special situation, where one set is a subset of the other, their intersection is the smaller set and their union is the bigger set. So everything in the bigger set, which includes the smaller set, is their union. That's a special case. The subset is a special case of the intersection of sets. Where we have three sets overlapping, as in set P, Q, and R, their intersection, of course, is where each set overlaps with the other. In the middle here, the elements in here are common to all three sets. That's the intersection of all three sets. The union would be combining all of the three sets. So when you think union, you're thinking what are the elements in both sets combined, right? Elements of this one plus the elements of the other. And the complement, no, complement of a set means what is not in. So set A listing all the elements of A. A complement, which is written as a little stroke to the top of the letter. Remember, capital letters are used to denote sets. The capital letter with a little stroke to the top indicates the complement, so that means the elements that are not in set P, right? So you can have the union of a set with an empty set. Remember, empty set means no elements. That would be like similar to adding 0 to a number, right? So it would be the one set that has elements plus the empty set that has no elements is still just the elements of the first set. When we are listing the union of sets, if there are elements that are in the intersection, we don't list those elements twice. So we just list them once. When we're listing the union, even the ones that overlap, when we're listing them, we just list them once. So let's go through now in order to make sure we understand what we're doing. Practice makes perfect. So let's look at the Venn diagram and list the elements of the sets. So we're going to list the elements. We're going to list the union for some. This is the symbol for union. It looks like a U, but it does not have the curve at the end like the capital U that we write for the universal sets. This is the intersection of sets. Looks like an N, but there's no little curve at the top. And again, this stroke to the right, the top right of this set, that is the complement. That's what's not in the set. So for set P would be the elements within this circle here, including the ones that overlap, including the ones that are in the intersection. All the elements of set P, and we list our elements in curly brackets, and we try to maintain some kind of order. So for example, alphabetical order, numerical order, that kind of thing. Not absolutely necessary, but we try to maintain some order. So for set P, we open our curly bracket, so that will be 1, 3, 7, 9, and 10. Those are the elements of set P. For P complement now, what's not in P, it will be everything out here. That once it's not in the P circle, it's P complement. So that means it's a lot of things we're going to do. So we have 2, 4, 8, 5, 6. We have 11, 12, 13, 14, 15, 16. 17, 18, and 19. Now, these are not members of any of the sets. They are part of the universal set, but outside of these. They are still listed in P complement. So let's just switch around these to put them in order. So let's put the 8, the 6, and the 5. Okay. Alright, so those are the members of P complement. What's not in P? How about Q? Set Q, so that's this circle there. The elements of Q, so that will be 2, 3, 4, 7, and 8. 2, 3, 4, 7, and 8. What's not in Q? So Q complement. What's not in Q would be everything outside of the Q circle. So that's 1, 5, 6, 9, 10. As well as 11, 12, 13, 14, 15, 16, 17. All of these are in Q complement, not in Q. Alright, so how about set R? So set R, that's this circle here. So that's 4, 5, 6, 7, and 10. That's set R. 4, 5, 6, 7, and 10. R complement, what's not in R, will be everything else. Everything else in the universal set that's not in R. So that's 1, 2, 3, 8, 9. As well as 11, 12, all the way down to 19. So remember, set R are the elements in R. R complements are the elements that are not in set R. How about P union Q? P union Q. So that means everything in set P as well as those in set Q. And for those that overlap sets P and Q, we're only going to list them once. So that's set P and that's set Q. So the 3, 4, and 7 are in the intersection of P and Q. We're only going to list them once. So that's 1, 2, 3, 4. 1, 2, 3, 4, 7, 8, 9, 10. That's the union of P and Q. How about the union of P, Q, and R? So that's P union Q union R. All three sets combined. The union of all of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The union of P, Q, and R. Now what does this say? The union of P, Q, and R complement. So that means what is not in P, Q, and R? What's not in P, Q, or R? So that means everything out here. Remember that's P, Q, R, so their complement would be everything out here. So that would be then 11, 12, 13, 14, 15, 16, 17, 18, and 19. Set U intersect V. Where does set U intersect V? Remember, we said this is a special situation where set V is a subset of U. If you want more elaboration on subsets, just check out the video that we did focusing on subsets. Everything in V is contained within U. So remember when that happens, their intersection is the smaller set and their union is the big set. So their intersection would be set V, which is 12. And their union would be everything, so that's 11, 12, 17. This is a subset. V is a subset of U. Alright, so how about S intersect T? Again, special situation. Set S and set T are disjoint. They do not overlap. They are neither subsets nor regular intersection. They don't touch, they don't overlap. So, their intersection then is the empty set. or the null set. So we can just put the empty set. These two symbols, either one, is used to represent the empty set. There are no elements in their intersection because they do not intersect, they don't overlap. But their union is everything in S, everything in T. They do have a union even though they are disjoint. So that's 13, 14, 15, and 16. So remember, that's very important. Even if two sets are disjoint, they don't intersect, we can still list their union. What does this say? P union Q union R union S union T, the complement of that. So everything in P, Q, R, S, T, the complement of everything in P, Q, R, S, T. So what's not in P, Q, R, S, or T? So that's P, Q, R, S, T. So their complement then would be 11, 12, 18, and 19. Alright, so just two more examples. Wherever you see one set intersecting the complement of another set, this means what is in this set only. Excuse me. So what is in P, what is in P only? Where P intersects the complement of Q. So what's in P only? So that would be what's in P but not in Q. What is in P but not in Q? So that would be 1, 9, and 10. Now the 10 is also in R, but we're not considering R right now. We're just focusing on P and Q, and we want to know what is in P that's not in Q. So that would be 1, 9, and 10. And this is the opposite now. P intersects Q, P complement intersects Q. What is in Q that's not in P? Alright? So what is in Q that's not in P? So this is Q, this is P. So we want the elements of Q but not where they overlap with P. So that would be 2, 4, and 8. Okay, so that's the basics for listing our union, listing our intersection. And if you want more information on the intersection, check that video. If you want more information on subsets, check that video as well as disjoint sets. Just remember, these are the basic ways that sets interact with each other in the Venn diagram. They can be disjoint, meaning they don't intersect. They can intersect like this, where we have them overlapping, whether it's 2 sets overlapping, 3 sets, or they can have a special intersection where all the elements in the smaller set are contained within the bigger set, and we call that a subset. If they are disjoint, they don't have an intersection, or we can say their intersection is the empty or null set. However, we can list their union. If one is a subset of the other, the smaller set is their intersection and the bigger set is the union. I hope that you have benefited from this video, and I hope you did subscribe. If you have still not subscribed, please do so now, and please share the video so other students may benefit. Remember, on this channel we have math videos, from grades 4 all the way to grade 11. We also have student motivation videos to keep you inspired, keep you wanting to learn. So check those out as well. Just look at the playlist and find what you want. Put up your tent and camp out on this channel. So my scholars, I'll see you in the next video.